Hi everyone, thanks for coming to AutoCon, and here's my talk. Automation transforms $70 access points into enterprise-grade networks. So first, a little bit about me. My name's Henry. I'm a software engineer at RGNets. I spend all day, every day, working on our product, the RxG, which is a combination router, firewall, account management system, hypervisor, payment processor, infrastructure management platform, and about 100 other features that would take me another conference to fully explain to you all the features. So all you need to know is that it operates at the head end of your network, and it defines and controls all the features that are the parameters of how people join onto your network, and how do they pay, do they get a policy of the content filtering, so on and so forth. So this presentation covers a project that I've been working on that combines three of my favorite things: Linux, Wi-Fi, and automation. So let's talk about the challenge. What is an access point? Well, it turns out that an access point is really just a Linux computer with 3 radios hanging off of it. You know, what else is a Linux computer with 3 radios hanging off of it? I've got one right here. We all do. But these enterprise-grade access points cost $400 to $800, or even up to $1,000. This Linux computer with 3 radios on it has a much lower cost, but it has a screen, it has a camera, it has a battery, it has a speaker, it has a microphone, and it has all these features that go above and beyond what I would argue an access point has, which is just the same Linux computer with 3 radios. So why is it that an access point costs $400 to $800, but a phone only costs $100 to $200 at the cheaper end? It's because manufacturers manufacture the devices, and then another company takes them and has the control plane and management plane onto the devices so that they can resell them for a much higher cost. With a community software such as OpenWiFi, we can use the OpenWiFi firmware, put those onto the access points, and use that firmware to manage the access points so that people can buy the access points directly from the manufacturer and put this software on it and use a disaggregated control plane layer in order to control the access points, which is exactly what I've been working on adding to our product so that our customers can use this to manage the access points, and they can buy these access points, use them, run them, and pay no additional licensing fee for any type of controller software to do so. So how does this work? First, the operator uses our product to configure all the parameters for their network. Our product uses the OpenWiFi controller to convert this into OpenWiFi configuration for the access point devices, and then sends that configuration to the access point devices. Simple, right? Okay. So here's some philosophy of rapid automation that I use to develop features for the RxG as fast as possible. First, we define the feature clearly. What does it do, what doesn't it do, and why? Then we do our homework. Figure out the APIs, the data flows, the inputs and outputs. Where and why is every transaction going to happen? Next, we begin coding. We develop the crude outline of the product from A to Z, and this is before we even try running the code or testing it or anything. We just start coding it, and then we figure out what it needs to do at every step along the way. While I'm doing this, I'm thinking about the data layer, the UI layer, and the action layer. The data layer is the data model, which is a very important part, because if you understand your data model, you understand everything. You're good to go. The UI layer is how the user interacts with your data model. How do they update it? How do they figure out what's going on? And the action layer is how your data model applies to actions that are taken on the network, and how does the data that your users are putting in apply to what is going on in your network. All right, so the most important parts here are feedback. Once I get the software running, I figure out the little bugs along the way as I refine and iterate it. Then I look at the feedback. When it comes to feedback, there's 2 important types. There's feedback from the machine, and there's feedback from the users. Here we have an example of feedback from the machine. I made it so that whenever possible, the errors that occur when pushing the configuration to the devices bubble up to the operators so that they can have something to do and tell us what the error is. And we get this feedback, this error report, and we use it to pinpoint exactly where the problem is, and that helps us iterate more quickly. Finally, we review and merge the feature. The next type of feedback is feedback from the end user. This is the most critical because they are the ones who are ultimately going to decide the success or failure of the product, but they're also the ones that are the most remote from where I sit. I'm working on the feature, we give the feature to the customer, they present it to their customers. There's usually another link or two in the chain somewhere, but those end users are so remote but so important. So one thing that I'm always trying to do in my day-to-day is think about how can I get as much feedback as possible from the end users, because that's what's really important. So now I'm going to talk about some of the features that we developed along the way in order to onboard these APs and use them. First, when we onboard the APs, we automate the entire process of getting the AP under the command and control of the RxG. The RxG SSHs into the AP, updates the firmware on the AP. We create the certificate signing request on the AP, transmit it to the RxG, sign the certificate signing request, transmit the signed certificate back to the AP. Now the AP knows what certificate it should use to figure out whether it trusts the world, and the world can know that it could trust the AP by looking at the certificate that the AP has. So this creates a mutual TLS connection between the AP and the controller, which also does a similar process to get a signed certificate from the RxG. So this extends the web of trust from the RxG to both the AP and the controller. Next is instrumenting the APs. Instrumenting means we get the information about what is going on the APs and bring that into the RxG so that it's in our single pane of glass command and control plane so that our operators always know whether the APs are online or offline and how many clients are connected, how much data is going to the AP, and so on and so forth. Next is really the most complicated one, and this is making sure that we know that every single type of SSID or configuration that might be necessary for any scenario, whether it's multi-dwelling unit, hospitality, or large public venue, is working. So here we have about 10 SSID scenarios that we've tested so that whichever type of configuration the operator wants, whether that's 6 gigahertz, MPSK, which is multiple pre-shared key, GRE, or hidden SSID, or WPA3, or EAP, they're all tested and they're all ready to go for the operator. So our operators configure the different SSIDs here, and we automatically generate that config and push it to the APs. Next is firmware. We use the open source OpenWiFi firmware, but we also sometimes need to add a little bit, maybe like 1% or less of additional functionality onto it. And we also include this way for our operators to acquire our firmware. So I built this for our operators to be able to just go in here, choose the version, choose their model, click acquire. That's about 3 clicks. They get the firmware onto the RxG, then it's just another few clicks to start pushing the firmware out to the APs. Very easy. So the results have been extremely promising so far. We have this working at 2 deployments so far. One is a hotel in Florida, and one is a first field application by AT&T in Dallas, Texas, that is going live literally today. And they are deploying it there, and we're looking forward to deploying it at many, many more places soon to come. So finally, I just want to say that the $70 number was always a bulk number for about 1 to 10K for Wi-Fi 6 APs that have a 1 gigabit uplink. And the price may have gone up a little bit, but the recent numbers that I've seen show that it's only gone up a little bit. So sorry about that. Thank you.
Thank you.